Okay, so in the last class we have discussed on a problem, and we have discussed on band break and solved a problem on simple problem on band break using data. Now we will move on to another problem. This question was asked in the university examination 2023. That is the last year. So just view it. ഇത് നമ്മുടെ യൂണിവേഴ്സിറ്റി എക്സാമിനേഷന് ചോദ്യമാണ്. ഇത് ഇനിയും ചോദിക്കാൻ സാധ്യതയുണ്ട് ഇതേ ടൈപ്പ്. കാരണം കഴിഞ്ഞ മെയിൽ ചോദിച്ചത് ബ്ലോക്ക് ബ്രേക്ക് ആണെങ്കിൽ ഇത്തവണ ബാൻഡ് ബ്രേക്ക് ചോദിക്കാനാണ് സാധ്യത. ഓക്കെ, now we can look into it. A simple right, so please look the question. A simple band break is shown in figure 1 and have the following data. A is equal to 250 mm, L is equal to 750, theta 25, R 250 mm. The width of the friction lining is 60 mm. The coefficient of friction is 0.4. The maximum intensity of pressure is 0.25 Newton per mm square. Calculate the band tensions on tight side and loose side, actuating force, the torque and the torque capacity of the brake. So here we have the figure is given and the dimensions are given. Also given the radius, the angle is all the data are being given. Here we are told to calculate the band tension on tight side and loose side. That is, since as you see from the figure that the brake is blocked, the brake drum is rotating in clockwise direction. The tight side will be, this is the tight side, which is which is F1 denoted by F1, and this is the slack side, which is denoted by F2. And here the force to be applied is not being given, that is the actuating force is P. It is not given, and we have to find it. Now first, when you get a problem, first you should write the given data. So these are the data given. A is equal to, first the radius R is equal to 250 mm. നമ്മൾ ആദ്യം 250 mm എന്ന് എഴുതണം. Then the theta is equal to 225 degrees. Either you can convert it to 225 degree. Either you can convert this into radians in the next during the next time, or in the coming slide, or during the calculation. So you can calculate it in this data, in this given data. So here I am calculating this into converting this into radians from the given data itself. So it is 225 into pi by 180. That is equal to, that will be equal to, the theta is equal to 3.924 radian, 3.926 or 926 radians. Okay, now the coefficient, we have given the coefficient of friction. The coefficient of friction, that is mu is equal to 0.4, and the width of the friction lining, that is the width of the friction lining, it is being shown, the friction lining or the bandwidth or the width of the friction lining is what? B. That is width of the band or width of the friction lining can be denoted by B, that is 60 mm. And the maximum intensity of pressure, that is the maximum pressure that can be applied here is sigma D. We call it as sigma D is equal to 0.25 Newton per mm square. Okay, that is you got that. And also the other dimensions, A equals 250, this is A 250 mm, and L is 750 mm. We have given, and the first thing is calculate the band tension. That is, we are writing the, first we will calculate the band tension. Band tension. Here, since we have in normal case, when we have given the force, we can calculate the band tension by using this above, using this from page 270, using the above, this figure you can calculate. Here, as you know, the band, since the bandwidth is since the F is not given, the actuating force is not given, we should find we should look we should look into another equation. Here we have the width of the band, B is equal to F1 by H sigma D. That is equation 13.184, where B is a width and sigma D is called the design stress of the band, or the design intensity of pressure we can take, and H is the band thickness. So here B, so from equation B is equal to F1 divided by H into sigma D. So sigma D is the intensity of pressure. H can be this is equation 13.18 and this is here sigma D is been taken, B we know, F1 we don't know, and H we can be calculated from the equation below, the above equation. H is equal to 0.005 into T, that is equation 13.18, and here the D is given as 250, the radius is 250, so H is equal to 0.005 into 250, that is equal to 2.5 mm. 0.005 into 250, sorry, 1.25 mm. 1.25 mm H. When you substituting the value, you get B. We have given the width of the brake lining. B is the brake lining. That is the width of the friction lining. That is the brake. It is 60 mm. 60 is equal to F1 divided by 1.25, and the intensity of pressure is, we have given sigma D is 0.25. From this you can calculate the value of F1. F1 is equal to 1.25 into 0.25 into 60, that is 1.25 into 0.25 into 60, that is 18. F1 is equal to 18.75 Newton. Also, we can calculate F2. As you know that F1 by F2 is equal to e raised to mu theta. Since we know F1, therefore F2 is equal to F1 divided by e raised to mu theta. We know mu is equal to 0.4 and theta is equal to 3.926. Therefore, F2 is equal to 18.75 divided by e raised to 0.4 into e raised to 0.5 3.926. So you will get the value as 0.926 So F2 will be equal to F2 will be equal to 3.89 Newton. Now you got the value of F1 and F2. So the first thing has been done. Now we need to calculate the actuating force. The actuating force can be calculated from the data book, from the figure. F, as we know, F is, from the second figure. Look, from the second figure, what F is equal to B into F2 by A. So A is here, A is equal to 750 and B is equal to 250. F2 we have already calculated. Therefore, actuating force F is equal to B into F2 divided by A. Data book page 270, equation 13.19C. Therefore, F is equal to B. The value of B, as you know, is 250 here from the figure. A, that is 250, and 250 into 3.89 divided by 750. 250 therefore F is equal to 1.299 Newton. Now the third, the torque capacity. Torque capacity. Here, torque can be calculated by either. You can calculate, we have the value of F, so you can calculate Ft from the above equation 13.19C, and you can calculate and multiply when you equate another equation, that is equate the 13.19C, that is this equation. If you do this equation, you and substituting the value of F, B, A and e raised to mu theta, you will get the value of Ft, and from that when you multiply by multiplying the value given, the obtained value of Ft with radius, you will get the torque. There is another method by using the data book, that is torque capacity. We know T is equal to look here, the torque capacity T is equal to F1 minus F2 into R. So that is equation, that is from the page 269. Below equation 13.18Q, we have just below T is equal to F1 minus F2 into R. So when you can substitute the value, you will get T is equal to F1 minus F2 into R. That is F1 is equal to, you got the value of F1 is equal to 18.75 minus 3.89 into radius 250. So you will get the value of 18.75 minus 3.89. You will get the value as 3715 Newton mm torque, or when you convert into meter as a unit, you will get 3.715 Newton meter. That is the torque obtained. That is 3715 by 1000 Newton meter. So this is the value of the torque obtained, or the torque capacity of the above brake. So if you have any doubts regarding this, you can answer, you can write or comment provided in the comment section given below. Okay, so you have, I believe you have understood this problem. If any doubts, you can free to write the comments below. Okay, thank you.